everybody, Miss Maritello here to talk to you about what scientific notation is. So we know that we have some numbers out there in the world that are so big or so small that they can be kind of annoying for us to write. So for example, if I was to think about the number, say 10 billion, it's going to look like a 10 followed by 000, 000, 000. And if I want to do operations or anything on that number, it's going to be kind of annoying every time that I'd have to write out all those zeros. So we use this form of scientific notation to make these numbers easier to write down, easier to compare with other big or small numbers, and then easier to do operations like addition, subtraction, multiplication, and division on. One example of a really big number could be the distance from here on Earth to the sun. It's about 91 million miles. We can rewrite that number in scientific notation as 9.1 times 10 to the 7th. So when we look at it, it's kind of like two parts, like a little math problem in itself, where we have a first factor, because it's multiplication factors, the first factor, and then the second factor. You'll notice that the first factor, it's bigger than 1, but smaller than 10. And then you'll notice that the other factor, the second factor, is 10 to some power, 10 to some exponent. When we go through that, and we've been talking about exponents already, 10 to the 7th is going to be like 10 times 10 times 10 times 10 times 10 times 10 times 10, 7 times. So we'd have 9.1 times those 7 tens all multiplied. If you were to go through that, it'd be like 9.1 times 10 million, which would be giving you back to the 91 million. A little shortcut on there that most people like to use is that if you were to look at 9.1 and you know you're going to be multiplying by 10 7 times, people like to just move the decimal 7 places over. And I know that because I have 10 to the 7th, I'm going to get a really big number, so that's why I'm moving it to the right. And same thing, I fill in all my zeros, and I end up with 91 million. Notice that it's not that I have 7 zeros, it's just that I'm moving the decimal over 7 places. If I was to do the same thing with a number in scientific notation that's very small, take a look at that second factor. We still have a power of 10, but now the exponent is negative. Think back, what do you remember about negative exponents? Oh, they always come out to be fractions, so it would be like 1 over 10 to the second, or like 1 over 100. So if I was to multiply that 3.45, the first factor, by the 1 over 100, it would really just be like dividing by 100, which gives us 0.0345. If you want to use the trick where you're moving the decimal place, you still can, but you have to be careful because since we see that negative exponent, we know that that would be a fraction or a decimal. I like to kind of think with scientific notation a very small number. So then instead of moving the decimal place to the right like we did last time, we have to move it 2 places then to the left. So then I get, same thing, 0.0345. So couple key things that we're noticing is that first factor, it should always be between technically greater than or equal to 1, and then always less than 10. And then that second factor is always going to be 10 to an exponent. So that's a little intro to scientific notation for you guys. Thanks for listening.